So you may be wondering now, why do we need the limit definition of a derivative? So let's talk about what we're actually going to use the limit definition of a derivative for. So for the limit definition of a derivative, what we really want is to remind ourselves what our function actually is. So our limit definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. We can put a number in, like our second one, or we have the limit definition at a point. So f prime of a is equal to the limit as x approaches a of f of x minus f of a, all divided by x minus a. So the big key here is that we just need to kind of see what our function is to kind of help us out. So when I look at this first one, the limit is h approaches 0, automatically tells me it is in this form. So in this form, what we're looking for is f of x. If I look at the top, we have x plus h to the fourth power minus x to the fourth. So x to the fourth is our function. So what this really means is we are taking the derivative of x to the fourth power. We now know what to do with that because of power rule, so I can go ahead and say 4x cubed, and I know my answer. So now I can look at this limit definition of a derivative and say, well, that's asking for the derivative of x to the fourth. That's 4x cubed. We're done. This second one, we have another h approaches 0, so we are looking at this first version. The only difference is that we don't have any x's here. So my first go-to would be looking at our function. Well, that's the square root of 2 over 2. But that doesn't really tell us what our function is because that's already evaluated. So if I look here at our x plus h, this looks like cosine of x. So the derivative that we are trying to take is cosine of x, but we're going to be evaluating it at whatever piece is in here. So pi over 4. So our evaluation notation is L bar, and then we would say something like x equals and then pi over 4. Okay, our last one here is t approaching 1/3, and it has a very specific kind of setup. So what we're looking at is this one right here. F of x is the very first thing here, which happens to be t to the negative first power. So t to the negative first power, which is the same thing as 1 over t, is what we are solving. And just like the first one, we can figure out what this equals. We have negative 1 t to the negative second power, or negative 1 over t squared. And all we're doing now is evaluating it at t equaling 1/3. So I could plug in 1/3. So we get negative 1 over 1/9, but I have something divided by a fraction, so I have negative 1 times our reciprocal 9 over 1, negative 9. So I can go ahead and figure out what it is without having to do a ton of work with our limit definition of a derivative. So this is going to be more of the focus for our limit definition of a derivative. We only really used it to kind of help us find a pattern, so that way we didn't just have a shortcut come out of thin air.